All right, so today we're going to be diving into some pretty wild science news.
Absolutely.
We're talking quantum computing.
Yes.
And specifically this new announcement from Microsoft.
It's a really fascinating announcement.
Yeah.
It is. And I think what makes it so interesting is that unlike a lot of the other big players in quantum computing, Microsoft has really taken a different approach here.
Yeah. And they've been working on this for quite some time.
Oh, yeah. This is not something that just popped up overnight.
No.
This has been years in the making.
Yeah, you sent me a whole stack of articles about this, and
There's been a lot of buzz about it.
my head's still spinning.
It's pretty mind-blowing stuff.
It is, and it's hard to even know where to start, but I think the best place to begin is with this chip, this Majorana 1 chip that they've announced.
Yeah, that's the heart of it.
And it seems like what they've done is essentially gone back to the drawing board and said, okay, let's invent the quantum equivalent of a transistor.
That's a great way to put it.
Like, what is that fundamental building block that we need to really make this technology work?
And that's a really important distinction because they're not just trying to improve upon existing quantum computing technology. They're really trying to create something fundamentally new.
Yeah.
And that's where this idea, the topological qubit, comes in.
Okay, so topological qubit, for those of us who aren't quantum physicists, which I'm assuming is most of our listeners,
Right.
break that down for me.
Well, the key thing to understand is that most qubits, which are the heart of any quantum computer, are incredibly sensitive
Okay.
to noise and disturbance.
So like the slightest change in temperature or vibration or anything like that can really throw them off.
Exactly. It's like trying to balance a pencil on its tip.
Yeah.
Any little disturbance and the whole thing falls apart.
Yeah. Finicky is a good word for it.
Yeah. Very finicky. And that's one of the biggest challenges in building practical quantum computers is how do you create these qubits and then how do you maintain their stability?
Right.
So what Microsoft has done is they've focused on this idea of a topological qubit. And they actually use this analogy of a knot in a rope.
Okay.
You can shake the rope all you want, but the knot itself stays put.
Okay.
And so the idea is that these topological qubits are much more robust,
More stable.
much more resistant to noise and disturbance.
Got it.
And that's what makes them so exciting because it potentially opens up the possibility of building much larger, more powerful quantum computers.
Okay, so these tougher qubits are what make up this Majorana 1 chip.
That's right.
Okay, so we've got these super stable building blocks, but what's the big deal about this chip compared to what's already out there in the world of quantum computing?
Well, most quantum computers that exist today operate with maybe a few dozen or maybe a few hundred qubits at most.
Okay.
Microsoft's goal with this new architecture is to fit 1 million qubits onto a single chip.
1 million on a chip the size of what, like a postage stamp?
Maybe not quite that small. Think more like the size of your hand.
Yeah.
But still, that kind of density is just unheard of.
Yeah.
And it really opens up a whole new realm of possibilities.
So we're talking about like tackling problems that are just way beyond the capabilities of any computer we have today.
Yeah, we're talking about things like, breaking down microplastics or designing completely new materials or, optimizing enzymes for all sorts of applications.
So like revolutionizing medicine, agriculture, energy, like all these huge fields.
Yeah, and there's this great quote from one of the articles I read where Chetan Nayak, who's a Microsoft technophile, said, whatever you're doing in the quantum space needs to have a path to 1 million qubits.
Yeah.
We have actually worked out a path to 1 million.
So they're not just dreaming big. They're saying, like, we have a roadmap to actually get there.
They have a plan, and that's what's so exciting about this announcement.
Okay, I'm starting to see why this is causing such a stir, but, like, creating these super stable, densely packed qubits, it all sounds incredibly complex. Like, how did they actually pull this off?
Well, that's where things get even more interesting. And it all hinges on a really special ingredient, something called Majorana particles.
Majorana particles.
Oh,
Okay, that sounds like something out of, like, a Marvel movie.
It does, doesn't it?
What are we talking about here? Like some kind of exotic matter?
These are not particles that you just find lying around.
Right.
They don't exist naturally. Scientists have had to figure out how to create them in a lab under very specific conditions.
So we're talking about, like, cutting-edge physics here.
Absolutely. And the key thing about these Majorana particles is that they have this incredible ability to protect quantum information.
Okay.
So it's like, imagine trying to trap a beam of light inside a box.
Okay.
Majorana particles are kind of like, they're very elusive. But once you've got them, they can hold on to this quantum information in a very stable way.
So they're like tiny little unbreakable safes for these qubits.
That's a great analogy. And that's what makes them so essential for building these super stable qubits.
Okay, so these Majorana particles are what make these super stable qubits possible, and Microsoft figured out how to build a whole chip around them.
Exactly, and that's just part of the story.
Okay.
Because controlling these qubits is another huge challenge.
Right.
Typically, it requires very precise analog control, which is really difficult to scale up.
So it's like trying to tune 1 million tiny little knobs all at the same time.
Yeah, it's a nightmare.
I'm getting stressed out just thinking about it.
Yeah, it's incredibly complex. But Microsoft's approach with these topological qubits allows for digital control instead.
Okay.
So it's much more like flicking a light switch on and off,
Okay.
rather than constantly fiddling with a dimmer switch.
Gotcha. So it's much simpler,
Right.
much more reliable, and much easier to scale up.
Exactly, and that's a huge breakthrough.
That's a game changer.
It is.
But I have to imagine building this entire system from these exotic particles to the chip itself wasn't easy.
Oh, it was a monumental effort. One of the articles mentioned that Microsoft actually had to invent an entirely new materials stack
Okay.
just to build this chip.
So we're talking about manipulating matter at the atomic level,
We are.
working with materials like indium arsenide and aluminum in ways that have never been done before.
It's cutting-edge materials science and engineering.
Yeah, so this is not just a computer science problem. This is a multidisciplinary
Oh, absolutely.
breakthrough.
It's physics, it's materials science, it's engineering.
Yeah.
It's all of these disciplines coming together.
Yeah, it's clear that this project took a lot of time, dedication, and resources, but the result is something truly groundbreaking. Like, they didn't just improve existing technology, they created something entirely new.
And that's what makes this announcement so significant. It signals a shift from, can we even build this, to how quickly can we scale it up?
The possibilities are suddenly very real, and that's both exciting and maybe a little bit daunting.
It is a little bit of both.
Yeah.
It really makes you think, like, what does that actually mean to have a million qubit quantum computer at your fingertips?
That's what I'm trying to wrap my head around. Like, we keep hearing about these potential applications, self-healing materials, revolutionizing medicine. But it almost sounds too good to be true, like science fiction.
It does sound like science fiction, but that's the thing about quantum computing. It's kind of pushing the boundaries of what we thought was possible.
So let's break it down. Like, let's start with materials science, for example.
Okay.
Right now, designing a new material is a lot of trial and error.
A lot of guesswork.
Yeah, mixing things together, testing them, tweaking the recipe. It can take years to get the properties you want.
Exactly.
It's like trying to bake the perfect chocolate chip cookie, but a million times more complicated.
Yeah, that's a good analogy.
So with a quantum computer, how does that process change?
Well, imagine having a computer that can simulate the behavior of materials at the atomic level.
Okay.
You could essentially see how different atoms interact with each other, how the structure of the material affects its properties.
So no more blindly mixing ingredients in the lab. You could actually design the material you need from the ground up with the exact properties you want.
That's the idea.
Yeah.
You could say, I need a material that's incredibly strong, but also lightweight and flexible. And the quantum computer could tell you exactly what atoms to put together in what arrangement to achieve that.
That's wild.
It's like having a blueprint for building materials atom by atom.
So what kind of impact could this have on different industries?
Oh, it'd be revolutionary. Think about aerospace construction, anything that relies on materials.
So we're talking about lighter, stronger airplanes, more durable buildings.
And it's not just about making new stuff. Imagine understanding existing materials better than we ever could before.
Okay.
Predicting how a bridge will withstand decades of wear and tear, or how a plane wing will hold up under stress.
So preventing disasters, making structures safer.
Exactly, and
Yeah.
even extending the lifespan of everyday objects.
Okay, my mind is officially blown. What else can we throw at these million qubit machines? I remember reading about some pretty exciting stuff in the medical field.
Oh yeah, the potential in medicine is huge right now. Developing new drugs is a really long and expensive process.
Right.
A lot of it involves simulating how molecules interact with each other, and that takes a ton of computing power.
And even our best supercomputers today are kind of limited in what they can do.
They are, so quantum computers could really supercharge drug discovery.
Okay, so we could design drugs that target specific viruses or even treatments that repair damaged cells at the molecular level.
Exactly.
It's like going from using a magnifying glass to having a high-powered microscope.
Perfect analogy.
Suddenly you can see things in incredible detail.
And it's not just about drugs themselves. Quantum computers could revolutionize how we understand the human body, how diseases work, even how our genes influence our health.
So it's like a whole new frontier of medical exploration.
It is.
This is all starting to sound a little too good to be true. Are there any areas where quantum computers might struggle? Like, what about something like climate change, where we need to model these incredibly complex systems?
Actually, climate modeling is another area where quantum computers could have a huge impact.
Really?
Yeah, right now our climate models are limited by computing power. We just can't capture all the variables, all the intricacies of the Earth's climate system.
So we're getting a blurry picture when what we really need is high definition.
Exactly.
Okay.
A million qubit quantum computer could help us build much more accurate models, allowing us to understand how the climate is changing, what the impacts will be, and what we need to do to mitigate those impacts.
That could be a game changer in the fight against climate change.
It could be.
It feels like these quantum computers could tackle almost any problem we throw at them.
It's tempting to think so, but it's important to remember we're still in the early stages.
Right.
There are hurdles to overcome, technical challenges to solve, ethical considerations to address.
Yeah, it's not just about building these powerful machines, it's about figuring out how to use them responsibly for the greater good.
Absolutely.
But there's no doubt that this is a pivotal moment in the evolution of computing.
We've gone from wondering if we could build a quantum computer to figuring out how to scale them up to tackle the world's biggest challenges.
And Microsoft isn't the only player in this game, right? There's a whole ecosystem developing around this technology.
There is. It's a global race to unlock the potential of quantum computing.
Speaking of which, one of the articles you sent mentioned something about Microsoft collaborating with other companies and even the government on this. I have to admit, I kind of skimmed over that part. Can you tell me more about that?
Yeah, so you might be surprised to hear that Microsoft isn't trying to do all of this alone.
Okay.
They've actually partnered with other companies like Quantinuum and Atom Computing, both big names in the quantum world.
So it's more a collaborative
Yes.
effort, like a quantum brain trust.
That's a good way to put it. It's about pooling resources, sharing expertise, and pushing the boundaries of what's possible together.
And it's not just about building the computers themselves, right? It's about developing the software, the algorithms, the whole infrastructure around quantum computing.
It's about building a whole ecosystem, and that's where the government comes in.
Okay, so how is the government involved in this?
Well, Microsoft is actually part of a program run by DARPA.
DARPA, the folks who brought us the internet.
The very same.
Wow. So the government sees quantum computing as a pretty big deal too?
They definitely do. DARPA is known for investing in high-risk, high-reward technologies, things that could fundamentally change the game, and they've clearly identified quantum computing as one of those game changers.
So what's Microsoft's role in this DARPA program? What are they working on?
They're in the final phase of a program called US2QC, which stands for Underexplored Systems for Utility-Scale Quantum Computing.
Okay, a lot of jargon in there. Break it down for me. What does utility scale mean in this context?
It means a quantum computer that's powerful and reliable enough to be used for real-world applications, not just in a lab setting.
Okay, so we're talking about solving problems that actually make a difference, things that impact people's lives.
Exactly, and the goal is to deliver the industry's first utility-scale, fault-tolerant quantum computer.
Okay, fault tolerant, is that related to those finicky qubits we were talking about earlier?
You got to remember how we said that even the most stable qubits can still be affected by errors.
Right.
A fault-tolerant quantum computer is designed to handle those errors gracefully.
So it can keep running smoothly even if some of its components aren't working perfectly.
That's the idea. It's like a quantum computer with built-in backup systems.
That makes a lot of sense, especially if we want to use these machines for critical tasks like developing life-saving medicines or controlling essential infrastructure.
Exactly. You need that reliability.
It sounds like there's a lot of collaboration happening in the quantum world. It's not just about competition. It's about working together to unlock the potential of this technology.
And that's what makes it so exciting. It's a global community coming together to try and solve some of humanity's biggest challenges.
But with all this talk of potential, it's important to consider the other side of the coin.
Oh, absolutely.
We've been focusing on all the positive applications, but are there any potential downsides or risks associated with quantum computing that we should be aware of?
That's a great question, and one that we should definitely explore.
It's kind of like a double-edged sword, right?
It is. There's always a flip side to these kinds of advancements.
So what kind of risks are we talking about specifically? What should we be keeping an eye on?
One of the biggest concerns is cybersecurity. A lot of our digital world relies on encryption, to keep information safe.
Right. Online banking, personal data, all that stuff.
Exactly. And quantum computers, especially as they get more powerful, have the potential to break that encryption.
Oh, wow. So everything we think is secure online could be vulnerable.
Potentially, yes. It's like having a master key that can unlock any door.
That's a scary thought.
It is, but the good news is that researchers are already working on new types of encryption specifically designed to be resistant to quantum computers.
So it's like a cat and mouse game.
It is a bit of an arms race, but it's a necessary one.
Yeah, we got to stay one step ahead. Okay, so that's cybersecurity. What other potential downsides should we be thinking about?
Another concern is the impact on jobs.
Yeah.
As quantum computers become more sophisticated, they'll be able to automate tasks that currently require human intelligence.
Right.
And some experts worry that this could lead to significant job displacement.
That's a valid concern. It seems like every major technological advancement comes with some degree of job disruption.
It's true, but it's also important to remember that new technologies create new jobs as well.
Right.
The key is to adapt to make sure people have the skills and training they need to thrive in this new landscape.
So rather than fearing the future, we should be focusing on preparing for it.
Exactly. Invest in education, focus on retraining, and be ready to embrace the opportunities that this technology creates.
Because it sounds like those opportunities are going to be huge.
They are.
It really does feel like this technology could fundamentally change the world as we know it, and it's both exciting and a little bit intimidating.
It is. It's a lot to process.
It is, but I think it's important to have these conversations.
Absolutely.
To really think about the implications, both positive and negative.
And to make sure that we're guiding the development of this technology in a way that benefits humanity.
Well said. Well, this deep dive has been incredibly enlightening.
It's been a pleasure exploring this with you.
Yeah, from those mind-boggling topological qubits to the potential impact on society as a whole, it's clear that quantum computing is a force to be reckoned with.
It's a game changer.
It is, and for our listeners who are as fascinated by this topic as we are, we'll be sure to include links to all the articles we mentioned in the show notes so you can delve even deeper.
Great idea.
But before we go, I want to leave everyone with one final thought. We've talked about how quantum computers could potentially design anything, perfectly new materials, life-saving drugs. But if we reach a point where we have all the answers, where creativity is essentially outsourced to a machine, what does that mean for us?
That's a really interesting question.
What happens to the joy of discovery, the human spirit of innovation?
It's something we'll all need to grapple with as this technology evolves. But maybe it's not about fearing the loss of creativity, but rather about exploring how quantum computing can enhance our own ingenuity.
I like that.
Pushing us to ask new questions, explore new frontiers, and imagine new possibilities.
So it's not about replacing human creativity, but amplifying it.
Exactly.
That's a really inspiring way to think about it. It's a reminder that even in the face of these incredible technological advancements, the human spirit of exploration and discovery, that's what will always drive us forward.
Couldn't have said it better myself.
Well, on that note, I think we'll wrap things up here. Thanks for joining us on this The World of Quantum Computing.
It's been a pleasure.
And until next time, keep exploring and keep asking those big questions.